Hello and Khushamadid. I am Ghazi and this is my maker's portfolio. Inspired by Alan V. Oppenheim's class on signal and systems, I worked on one of my favorite projects yet, a control system designed to balance an inverted pendulum. The three main components were the hardware, the electronics, and the code. Starting off, I used an aluminium sheet and a linear guide from an old machine. Then for the trolley, I went for a 3D printed head at first, but its structure was nimble and all the forces of the pendulum were loaded onto the potentiometer. I then designed a different part and machined it on a lathe and milling machine at the factory. With this version, the weight of the pendulum was balanced by a shaft which then turned the potentiometer using a belt. This design was both complex but worked. After this, I mounted the pendulum on the shaft and connected the trolley to the 3000 RPM DC motor using a belt pulley system whose gears were 3D printed. With this, the mechanical section was completed. Moving on to the electronics, I used a 10K potentiometer for the angle, the BTS7960 driver, an Arduino Uno and the ADS115 amplifier, which are short-circuited and average out the reading to reduce noise. Then I braided the pot wire to reduce interference. Soldering everything together concluded the electronics section. Now onto the code. I used the ADS1X15 library to run the ADC. The PID controller has three parameters: the proportional gain, which determines how fast the system responds, the integral term, which determines how fast the error is removed, and the derivative term, which predicts the rate of change of error. And now the moment of truth. It works, but it is not smooth. Using an oscilloscope, I measured the noise in the potentiometer, and here is, as you can see, a lot of noise can be seen. Over the next 2 months, I will work to fine-tune the system and reduce the noise. With control systems implemented in simple things to even rockets, this is just the beginning to what I want to achieve in the future.